We did this Friday, but we added to it since then. So you probably have most of this written down already. But since it's a Monday, I'm going to start from scratch. Indeterminate forms. The main two, 0 over 0, infinity over infinity. If we have those, we can do L'Hopital's. So those are the goals. If we have an indeterminate form, we have to turn it into one of those so that we can do the whole L'Hopital's rule. But they're not the only situations that we see. We have an indeterminate product. What's the indeterminate product that we don't know? Infinity times 0. We don't know what that is. So we have to write as a fraction. And then we should be able to do L'Hopital's. Okay, and remember we put it as a fraction by putting the reciprocal of one of them on the denominator. We had an indeterminate difference. What's the one subtraction we don't know? Okay, and that's the same thing. We need to get it as a fraction, so usually that means common denominator. Then you can write it as one thing, and you can do L'Hopital's. Alright, and then we had our our exponentials. What were the 3 exponentials we didn't know? 0 to the 0, infinity to the, and 1 to the infinity. And with any of these, we add the natural log, write it as a fraction, do L'Hopital's, and the answer is e to that number, because we had to add the e to cancel the natural log. Alright, so that's everything we've done. When you get ready to do some review problems here in a bit, this is probably what you want to look back and reference, kind of all of the different indeterminate forms. If it's not one of these forms, can we do L'Hopital's? No. Then you have to figure it out using some other method. So you have to verify that it is one of these forms before you jump into L'Hopital's. Alright, so the last problem we have, let's look at it and figure out which indeterminate form it is. So x, we're approaching 0, so that would be 0. Tangent of 0 is 0. So 0 to the 0 power, is that indeterminate? Yes. It's one of those 3 that we just wrote down, 0 to the 0. So our strategy, first we have to add a natural log. So we're thinking natural log of the argument. And why do we do that? So we know our answer will be e to some power. And the reason we like this is because then properties of logs, your exponent comes down. Okay, but I have to ultimately turn this into a quotient. So how will I do that? We can move 1 to the bottom by doing its reciprocal. We don't want to do the reciprocal of natural log. That's not nice. But we can make it a cotangent on the bottom. Mathematically, those are the same. Okay, natural log of 0. We've talked a lot about natural logs. We know the graph looks like this. As it's approaching 0, you have a horizontal asymptote, so that's going to negative infinity. Cotangent of 0. If tangent is 0, what's cotangent? Undefined. It's a reciprocal. So that means it's a vertical asymptote at 0. So we have an indeterminate form, infinity over infinity. So we can do L'Hopital's. Okay, derivative of a natural log is 1 over the argument. What's the derivative of cotangent? Let's try to clean this up. Cosecant is the same as what? So if we flip and multiply, this is equivalent to negative sine squared x over x. What's the sine of 0? 0 over 0. So what's that mean? Again. Okay, so sine squared, exponent comes down, inside stays the same, subtract 1 from the power, times derivative of the inside, derivative of sine is cosine. Oops, I did not write my limit, shame on me. Over, derivative of x is just 1. Is everybody with me so far? Why did I do all of this stuff instead of just doing L'Hopital's again right here? Yeah, it was just prettier. Does that mean I couldn't do it here? Absolutely not. You could have. But at some point you're going to have to simplify this. So just remember, any simplifying along the way that you can do will make your derivatives nicer and give you easier things to look at. So we have negative 2, sine of 0 is 0, cosine of 0 is 1, so we get 0. So my answer is e to the 0 power, which is 1. So I have problems for you to practice. If you write big, you might want to do a separate sheet of paper. Give yourself one.